And guess what, space weather enthusiasts? We've got yet another coronal mass ejection headed our way. It's exciting stuff. You might be able to see a little brightening happening in the lower right of the closest star right down there. That is an Earth-directed CME. We'll talk about it and lots more tonight at the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. We're delighted to have you. It's called Advanced Stargazing. That's the past 24 hours from SDO, the Solar Dynamics Observatory. And let's take a little closer look here at this location where this latest Earth-directed CME occurred. You might see some hider flare action happening there as some of that ejecta is on its way toward your door. Yes. Yes, exciting stuff. And don't forget to press like if you enjoy the content. Oh, and by the way, here's some difference imagery as well. That is just frame subtracted by frame. So it's actually the same wavelengths we were showing. And you'll see down there, you'll see that CME happening right there. And by the way, the following are paid promotions for the support of this channel. If you like these videos and you'd prefer to see them continue to exist, remain publicly visible and free for all to view, consider becoming a member of the Smash Team at smashomash.com/Smash Team, the official subscription services site of the Smash News Network, least busted name in news. If you want additional content, that's where to get it. Become a gold or a silver level Smash Team member. Even bronze level members get email alerts about videos like this one and disaster alerts and lots more. Smashomash.com/Smash Team to support the channel. Today's featured product is the one that I'm wearing today. Yes, the pink flamingo Hawaiian shirt. I'm a huge collector, so if you want to pick up one of your own, Amazon.com/shop/Smashomash. That's another paid endorsement. Here's another paid endorsement, Hemp Lucid. Don't forget to enter the promo code SMASHOMASH10 to save 10% on your Hemp Lucid purchases. There is a link below the video to our Hemp Lucid shop. Again, enter the promo code SMASHOMASH10 to save 10% on your order from hemplucid.com. Thanks to everybody who's helped support the channel those ways. Today's featured product is some advanced trolling. Yeah, advanced trolling. We don't screw around. And we don't shartlight. We don't even gaslight, but we certainly don't shartlight. Today's featured product is the Croissant Earth Society. Yes, when will you stop believing NASA's lies and start realizing that Earth is shaped like the French breakfast pastry? Not an oblate spheroid, not a pizza crust, not a snow globe with a sky dome. Are you kidding me? Earth is shaped like a croissant. Everybody who watches the channel knows that. When will you stop believing NASA's lies? Pick up some Croissant Earth Society merch from our Redbubble shop. 36 other designs available there on dozens and dozens of different types of products. Yes, if you'd like a sharp lighting miniskirt, we've got that covered. And you can find the links below this video as well as on the homepage at smashomash.com. So once again, thanks to everybody who's helped support the channel, especially the Smash Team. Smashomash.com/Smash Team. Welcome to the Neo Renaissance. Visit our links. Hit us up on social media. More on that a little bit later in the video. And let's get back to some stargazing, shall we? All right, fantastic. So here is November 8th and November 9th to date. We've seen a little dip in the sunspot number since yesterday, but things have been mostly stable for the past 24 hours. It looks like there's at least one new sunspot group way up in the northern hemisphere there, just in the western heliographic longitudes. And here is the SDO colorized magnetogram. The same dates there, November 8th and November 9th to date. So, looking at volcanoes briefly, we only have one on the list here from Volcano Discovery. Only Popocatépetl currently exploding, flight level 210 over central Mexico. It's a 21,000-foot plume of volcanic ash. I guess only one volcano is erupting at the moment? I don't know. I'm over it. Next, moving on to seismic activity. And there are the past 90 days. And if you watched yesterday's video, you might have seen this 7-magnitude earthquake drought has ended. Again, see yesterday's space weather video for more details on that. These are the quakes of the past 24 hours of a 5 or greater magnitude. So the day started out quite calm. No 5 or greater magnitude quakes until about 9:14 this morning, when a 5.1 hit Indonesia there, due north of Australia. And then Vanuatu had a 5.1. northeast of Australia. That was at 1412 Universal Time. It was also at depth. Then Peru had a deep quake as well, a 5.1 at 114 kilometers at 1750 Universal Time. And last but not least, New Guinea had a 5.4. So most of that activity there in the West Pacific, 1.5 or greater magnitude quake on South America, and it's time to return to space. So there's another 24-hour video for you, the SDO 171 angstroms wavelength. And let's take a little closer look. So that CME erupted about 10 o'clock this morning on November 9th. We can expect the coronal mass ejection to arrive sometime after midday on November 12th. Yeah, November 12th. NOAA and NASA. Well, NOAA agrees with us. NASA has not modeled this one yet. I'm sure by tomorrow's video it will be on the model because it's quite a significant Earth-directed CME. And let's start talking solar stats. So the 10.7 centimeter radial flux has dipped. It is now at 139 solar flux units. 139 is the new radial flux number. And there is the one-year graph of the radial flux represented by that black line there. The red line is the sunspot number. And here's our space weather enthusiast dashboard, and we don't see the forecasts for any CME impacts there on NOAA's scoreboard. However, yeah, one certainly about to arrive, and we're expecting actually one to arrive sometime in the next 12 hours as well, because we actually cited 3 CMEs. One was a very weak impact, if you can even call it an impact. The other one expected to arrive sometime early in the day tomorrow. See our previous space weather videos for those forecasts. And yeah, so here's the model. There's the model from NOAA. And yeah, expecting it sometime after midday on November 12th. So that CME was quite well directed toward the Earth. Their model looks a little funky, but hey, I'm not going to argue with that. At least they have it modeled, and at least the timing looks like it's pretty consistent with reasonable forecasts. So that's NOAA's forecast. Again, NASA has not modeled that one yet. So I suspect by tomorrow's video that will be up. We'll show it. Next, the last 4 hours of Earth's magnetic moment from space. So here's magnetohydrodynamic pressure. And we are seeing a continued subsiding of the solar wind here for the past 4 hours. We're back to geomagnetically calm conditions following a few days there of some significant geomagnetic storms. And we're going to talk a little bit about red aurora toward the end of the video as well. Make sure you stay tuned for that segment. A little bit of info about red aurora for you, as it's been all over the internet. Here are the past 4 hours of Earth's magnetic moment from the ground. And once again, looking like there is absolutely nothing to panic about or be spooked into your bunker over. So that's the past 4 hours of changes to Earth's B field and not a lot of reverberations happening at the moment. KP is 2.66 at the moment. 2.67 will round it to 2.67, folks. That's the KP index, an average of global geomagnetism. And moving right along to our real-time solar wind, the ACE is not actually showing anything. That actually is the ACE, believe it or not. See, I've got ACE selected. I pressed OK. And it's just the ACE is not sending data, but there's the Discover's data. About 6 3/4 protons per cubic centimeter for the solar wind density. Solar wind velocity here, a little under 500 kilometers per second at 484. And check it out. Here's a little weak CME impact. Basically a brush past. So a prime example there, you can see the variations in the plasma temperature, variations in the solar wind speed, and variations in the solar wind density. So not even a lot of changes happening in the magnetic field there, but it looks like that has subsided. Again, we are expecting one more before the more major CME impact. And by the way, the CME impact that we're expecting on the 12th, we could see as high as, once again, a KP7, maybe even a KP7.33. So It's quite earthly directed. It all depends on the magnetic field orientation and strength. Also, of course, the solar wind density and speed will matter, but anyway, there's a little tiny CME impact right about when forecast. If you watch a couple days ago, you would have seen that one on the forecast. Next are GOES magnetometers, and they are pretty chill here as well. Again, that CME impact was barely even detectable. It actually featured a weaker wind than the background coronal hole high-speed stream. Next, our line of sight, our top view ecliptic plane field plot, rather. As Earth is not going to spend a lot of time in this North Pole current sheet. Now, it might still be here when we get to tomorrow's video, as we have seen a little bit of an extension of that field. That could be an indication that we're going to see a sunspot form in the southeast. So there's a forecast for you. Sunspot possible in the southeastern limb in the next 24 hours. So that's all based on knowing how to read that top view ecliptic plane field plot data. It's one of the best predictive models that we have in all of space weather. Facts. Here's our line of sight field plot. And again, don't be surprised to see a sunspot form or rise somewhere around this area. So there's a little forecast for you. Enjoy that. You can watch tomorrow's space weather video and see if I was correct. Here's our line of sight ecliptic plane field plot. A little bit of magnetic indecision happening once again in the eastern limb, which brings us to coronal holes. So at the moment, we've got north and south. So these are north, and all the rest of these are south pole coronal holes. There's this small current sheet right here that the Earth is currently in a North Pole sector. Should be less than 48 hours, probably something more like 36 hours until we see that another South Pole current sheet showing up. And I'm talking about this right here, this sector boundary crossing. Probably about 36 hours out, I would say. And let's get the sunspots. So sunspot number has dipped a little bit here. It's just kind of hovering right around the average. There you go. There's sunspot number. It's at like 105, 103, something like that. 103 sunspots currently the number. And here's our flare probability and scoreboard. And let's see. It looks like the most likely place for a large flare is sunspot 3483. 3483 and 3477. So these two spots right here, this one here and this one down here, currently the most likely place to see a large solar flare. So let's take a look at sunspots here from, first a close-up of coronal holes. There you go. And a great view of that CME also. Here's the sunspot wavelength, SDO continuum that is. Visible light, basically, and then you've got the 94 angstroms to highlight active regions, and we'll also show the SDO magnetogram here. So a little bit of growth in this group up here in the northern hemisphere. Besides that, mostly stable on the Earth-facing portion of the solar disk. We'll let that play through in its entirety before we move on to energetic particles and solar flares. So that's the scenario, and not only have we seen that Earth-directed CME, but there has been a solar energetic particle event. So finally an SEP after weeks without any. There's the GOES proton flux. And we are getting close to where we might see some polar radio blackouts, although it does look like it has leveled off here. So just in the past hour or so, it looks like it may have leveled off. A little spike in the GOES proton flux there associated with that coronal mass ejection. And a great example of how you don't need to see a major solar flare to see a solar energetic particle event. Now, one of the places you might be able to follow that if it gets a little higher is at polar radio blackouts. And you can see a little bit happening there, mainly around the southern polar region. That is those protons emitting radiation there. But it looks like it's going to subside, so we'll have barely any polar radio blackouts from that proton event. And by the way, what we're looking at there is the attenuation of the D region, the attenuation of the frequencies there in the D region of the ionosphere. This affects what radio frequencies will be sent out into space as opposed to making it to its intended target on the ground. So there was no major flare there, just this C-class event. So a prime example of how you can see a significant solar energetic particle event with only a CME and no major flare to accompany with it. Remember, folks, coronal mass ejections and solar flares are separate events. Solar flares are photons of the X-ray variety, and coronal mass ejections are protons. Think of a fan as protons and a flashlight as photons. Very different things. And let's look at SDO. There is 94 plus 131 angstroms. 2 wavelengths specifically utilized to view solar flares. And that SEP likely came from somewhere in this area as that coronal mass ejection blasted off, defying gravity and being flung into the greater solar system. So let's take a look at a star chart next. Let's orient ourselves in the solar system, shall we? So this is where things are now. We've got Saturn and Jupiter over Lehigh Valley, Pennsylvania. That is our location. Just put in your own at skyandtelescope.org if you want to make your own star chart, and here is a solar system forecast. So we're showing you where things are today. Here's where things will be in 1 week. As Venus speeds away and Mercury rapidly catches up. We will have a crescent waxing moon by the 16th of November. And here's the astronomy photo of the day. This is the Crab Nebula. So this is the Crab Nebula is kind of important in that the Crab pulsar is actually used to calibrate background X-ray levels. So in order to calibrate X-ray, it's a consistent X-ray source. It's a strong and consistent X-ray source. It's used to calibrate X-ray telescopes. And the Crab pulsar is actually right in here. This is kind of zoomed out, but that's where the pulsar is. There is a pulsar wind nebula in there. The Crab Nebula is a very interesting one indeed. Considered to be a, quote, supernova remnant, end quote. It does have that Crab pulsar in the center of it, a major X-ray source in the Milky Way galaxy. That's the astronomy photo of the day, the Crab Nebula, one of the more picturesque nebulas that you can view. And let's get to CMEs, since there are some major ones, well, at least one major one, that is once again directed toward Earth. So this is, let's view yesterday first. There are yesterday's CMEs. And those are not earthly directed. And we'll switch to today, and right in here, almost a perfect halo there. So that is a quite earthly directed CME. Let's let that play through one more time, and there it goes, or should I say here it comes, because it does. And there it is once again. So here we'll also show Soho-Lasco C3. And there once again you see that halo erupting. A halo coronal mass ejection is the kind that is headed directly toward the SOHO spacecraft. And the SOHO spacecraft is right between the Sun and Earth, which means that's headed directly toward Earth. So we'll actually bring that one back here. There it is on C3. Quite a perfect halo there. And there it is on C2. Let's see what it looks like from stereo A briefly. It is located right about here, the stereo A coronagraph. Here it is on the left with the difference imagery on the right. Let's see what we get here. I haven't viewed this yet. It's looking a little old. Let's hope it's got up-to-date data. I'm hoping. Fingers crossed, folks. All right, so it looks like we're on the 9th. And here it comes. It's about to happen. There it goes. There it is. And it did show up pretty well there on the difference imagery also. So halo CME and some energetic particles there as well. Great imagery there, and let's cut to our custom coronagraphs. There you go. Earth-directed coronal mass ejection. Here we've shown the same images there. That's, once again, that's SDO 193 angstroms. Soho LASCO C2 NC3 running difference imagery of 60 minutes. Really get a great view of that ejecta. And here we've moved in a little bit closer and put back the raw images. Here's an even closer view. We've added 304 angstroms and subtracted Soho LASCO C3. Yes, good stuff. And here's 193 by itself. We'll also show 304 angstroms by itself. Once again, that CME came from this area right in here. And here it comes. Here's ionized helium. Wait for it. And it's on the way. So, how you like them apples, folks? 2 more CMEs on the way, and we've still got more space weather to cover. So let's blast through it. Next on our list is solar filaments. So here's what's going on with solar filaments. There are still quite a few. Yes, quite a few indeed, according to Big Bear's solar telescope. Check it out. There's a group of 3 down here. There's a big one down here at the South Polar region, a big one rising up in the northeast, a big one up here in the northwest. Some filaments here, filaments, lots of filaments, folks, lots of filaments. So that's what's going on. Here's a gray imagery. It shows prominences also, which is just a filament that's hanging off the edge of the disk. And we've got some in the west, mainly in the west, although some in the east also. Once again, that's a Big Bear hydrogen alpha telescope. And before we get to bonus features, here are the past couple of hours from the GOES. The GOES 16, that is. And let's blast through bonus features. So the first thing we'll cover is telling you to press the like button, press subscribe, press share, etc. Thanks to everybody who has supported the channel. Now, if you haven't seen our community posts, we suggest you check them out. You might be missing content there if you don't see the community posts. It's youtube.com/smashomash/community. And we do have various different types of posts in there, but the one I'm going to bring attention to today is the red aura over Arkansas 12 years ago. Yeah, 12 years ago. So here's a clip of this. If you think it's not the aurora, think again. It'll be super obvious that it is indeed the aurora. Check this out. That is 100% the aurora, and that is 100% red. That is over a solar cycle ago, and that is in Arkansas. So this has been a known phenomenon for maybe even over 100 years, but certainly for decades. So we'll play that again briefly. Red aurora there over Arkansas during the last solar cycle. So I know there's a lot of alarmism. Oh no, the aurora, it's going to kill us, and so on. We posted an article on Twitter also, so if you haven't seen it, check it out. There's an article on Twitter. It will lead you to a science paper where somebody studied this. And while it is not known what causes the sporadic aurora, check out the conclusion. The conclusion states, sufficient data now exists to demonstrate the reality of an auroral phenomenon under the conditions of quiet to moderate geomagnetic activity, and at latitudes much lower than those at which aurora normally occur, except for major magnetic storms. Explanation of this phenomenon presents a puzzle in magnetospheric geometry and dynamics, where we are looking for ways in which small bunched groups of particles can be ejected far into the closed field lines of the magnetosphere. So it's been known about. It's not really something new. And space weather is still not going to kill you. Sorry, folks. It's not doomsday. So satellite charging hazards are next. We do have some minor surface charging hazards there over the Middle East and the Western Indian Ocean. The GOES electron flux here in warning levels for both the GOES 16 and GOES 18. There's the 1-year graph of the relativistic electrons. Get that out of... Shut up that mutt. Go ahead, say it aloud, folks. Shut up that mutt. I dare you. I dare you to shut up that mutt. Anyway, there is the forecast model from NOAA. NOAA expecting a mild to moderate uptick in the electron flux in the coming days, and I have no reason to disagree with that. I'll say I agree. I agree with that model. Next, the F layer, the layer where that is measured. And let's actually switch to the full screen view for this. Here comes the F layer of the ionosphere and its vibrational frequency. It's at about 300 kilometers of altitude, if you're wondering. And it's pretty chill right now. Nothing major going on in the ionosphere. If you want to see some scintillation, view our video from a couple of days ago when there was a geomagnetic storm. At the moment, things are pretty chill. This is the anomaly from the 30-day median in megahertz. Again, things are looking quite normal. If you were hoping that we'd be showing evidence of doomsday, it's certainly not in this imagery. Anyway, there's 2300 universal time ionogram, 2300 universal time anomalygram. Here is the whole atmosphere model, the global ionospheric nowcast. It depicts likely GPS errors on the left and likely maximum usable radio frequencies on the right. A quick snapshot of the whole atmosphere model there. The whole planet view concisely shown right on your screen. We also showed the total electron content by itself. Feel free to pause the video on this frame if you're not familiar with distances to things like your GPS satellite. They're at about 12,500 miles of altitude. And here it is. The total electron content. Literally accounted free electrons from ground level to about the inner portion of the outer Van Allen belt. We also like to show the total electron content anomaly from 10-day average over North America. And there it is. The total electron content anomaly from the 10-day average over North America. We are seeing some high electron content anomalies once again over the west coast of the U.S. So that might mean something, that might not mean something, who knows? We show it because occasionally, folks, in science you end up with answers to questions not asked. So let us know what questions you're asking in the comments. Next, this is the latest intensitygram and latest colorized magnetogram. So that's what's going on. Let's take a look at these two sunspot groups here. This one is somewhat interesting. It is currently beta gamma class. Meanwhile, this one up here, that looks like the most active sunspot to me. That one is, whoops. That one is also beta gamma class. Is it beta gamma delta? Well, Yeah, actually it is. That's Beta Gamma Delta class, so that's the most likely place to see a large flare, in my opinion. This sunspot right in here. So that's my opinion. I'm sticking to it. And let's move on to meteorology. Now, we used to make these videos separate, but not anymore, because that simply lowered our views on YouTube. Yeah, we get lots of advice. People who don't make content on YouTube have a lot of advice. So if you've got some, by all means, leave it in the comments. We're looking at sea surface temperatures and surface winds here for the North Atlantic. So that's what's going on as far as ocean temperatures at the surface. Here's the Arctic Ocean, surface winds and sea surface temperatures. How about the full Atlantic view? There you go. There's the full Atlantic. And switching to the Southern Ocean, there you go. There's the Southern Ocean view. How about the Indian Ocean? There you go. There's the Indian Ocean. And last but not least, the Behemoth. The world's largest surface heat sink, folks. It's the Pacific, covering almost 1/3 of the planet. And let's switch to our regularly scheduled meteorology. There are the surface winds of the east. Here are the jet streams of the east. And let's pause for station identification. You've reached the Smash News Network, least busted name in news. Here are the jet streams of the central world. Shout out to my viewers from the central world. Shout out to our viewers from the central world. Here are your surface winds. And here are the surface winds of the west. Shout out to our viewers from the west. Like sands through the hourglass of time, these are the jet streams of your lives. Next, looking at clouds and fog. Here's the clouds and fog view for the Americas. It's shortwave radiation. As we approach the winter solstice, it's getting darker and darker when we make these videos. That's the current situation. And here's a slightly more zoomed in view. And here's the precipitation type map, and we've got some freezing rain falling in parts of New England, like northern New Hampshire, parts of Vermont and Maine. So some pink on the map there, that's freezing rain. Don't be driving in the freezing rain, folks. If you've got studded tires, I guess it's okay, but beyond that, dude, freezing rain is pretty berserk. There's your precipitation type map, as there is some white stuff falling, mainly north of the Canadian border. Next, our weather.gov map. If your location is lit, please head to weather.gov and get your own weather warnings if you need them. Weather.gov is the homepage of the National Weather Service, and here comes some forecasts, starting with the GFS 72-hour pressure and precipitation model. There you go. That's what's going on. Heavy moisture coming to the Pacific Northwest, both in the form of rain and of snow. Here's your total accumulated snowfall, your positive snow depth change in inches. Some areas they're expecting like 2 feet of snow in places like British Columbia and also in Washington. Yeah, Washington. Also some snow coming to New Mexico. Next, surface winds and mean sea level pressure. And we'll close out the forecasts with the GFS Jetstream forecast. So in the next 3 days, the jet stream will be doubled up over the eastern U.S., but most of it north of the Canadian border, bringing some warmer temperatures back to the center of the country. Next, lightning. That's where it's been striking for the past about 10 hours. And here are the current strikes. We did see a little bit of activity here south of Memphis. And at the moment, looks like no strikes in the U.S. Pretty light as far as lightning goes on a global scale here, only 4.7 strikes per minute. It's a pretty slow time right now for lightning. There is some in the central Atlantic Ocean, though. Anyway, we'll close this video out with U.S. Doppler radar. Ta-da! And we'll be focusing on the lower 48 as moisture makes its way from Texas up toward Pittsburgh. Here is clouds and fog depicted by the shortwave radiation satellite. And here is water vapor. Atmospheric river once again showing up from California all the way to British Columbia and beyond. Here's a recap. U.S. Doppler radar. Don't drive in freezing rain. Clouds and fog depicted by shortwave radiation, part of the infrared spectrum. And water vapor, another portion of the infrared spectrum. And here's me signing off. And while I'm gone, may that solar wind be at your back. Whoa!